Hello everyone, I am John P. Apostol and this would be the continuation of our report, Production of Aggregate, Concrete, and Asphalt Mixes. So next would be the table 7-4, Maximum Water Cement Issues, Material Ratios, and Minimum Design Strengths for various exposure conditions, adapted from ACI Section 318, ACI for American Concrete Institute. So the first exposure condition is concrete intended to have a low permeability when exposed to water. So its water to concrete ratio is 50% or 0.50 and the minimum design compressive strength is 28 megapascal or 4000 psi. The second one is concrete exposed to freezing and thawing. In a moist condition or de-icers, maximum water cementitious material ratio by mass of concrete is 45% or 0.45 and the minimum design compressive strength is 31 megapascal or 4,500 psi. And lastly, for the corrosion protection for reinforced concrete exposed to chlorides from de-icing salts, salt water, brackish water, seawater, or spray from these sources, water to cement ratio is 40% or 0.40 and the minimum design compressive strength is 35 megapascal or 5,000 psi. So the next table is 7-5 recommended slumps for various types of construction, adapted from ACI section 211.1. So for concrete construction, reinforced foundation walls and footings, the maximum height of slump is 75 mm or 3 inches and the minimum is 25 mm or 1 inch. For plain footings and caissons and substructure walls, the maximum slump is 75 mm and the minimum is 25 mm also. And for beams and reinforced walls, the maximum slump is 100 mm and 25 mm for minimum. For building columns, the maximum slump is also 100 millimeters and the minimum is 25 millimeters. And for pavements and slabs, for the maximum slump, 75 mm and the minimum slump is 25 mm. Lastly, for the mass concrete, height of the maximum is 75 mm and for the minimum is 25 mm. So yung procedure is first magsaselect muna ng water to cement ratio na nagsasatisfy sa requirements of for concrete, strength, durability, and water tightness. So na makita natin kanina sa table 7-4. Next is magsaselect naman tayo ng workability or slump required dito na sa table 7-5. Of course, ang susunod is mixing na nung trial batch using a convenient quantity of cement at the selected water to cement ratio. By then, i-add na natin yung quantities of saturated, surface dry, fine, and coarse aggregate until ma-reach natin yung desired slump na pinili natin dito sa table 7-5. After weighing each trial, the yield of the mix and the amount of each component required for a full-scale batch can be calculated by the method na i-discuss ko later. So yung next topic would be about batching and mixing. Batching. So first, what is batching? Batching is the process of proportioning cement, water, aggregates, and additives prior to mixing concrete, na nagre-require ng 1 to 3% accuracy. But still, dependent naman ito sa mixed components. That is why it is carefully proportioned by weight. Usually, ang batching plants na nagko-consist of separate aggregate and cement batching units ay gumagamit ng servicing track mixers for feeding and transporting of central mixing plants. Kaya usually, they are handled in bulk. Then, cement for mixers is usually measured by sack of 94 pounds or 42.6 kilograms. So, additional information lang about batching is magpe-play po tayo ng short video.
Hey guys, welcome to Civil Mentor. In today's video, I am going to discuss about the methods of batching of concrete. The process of measuring ingredients or materials to prepare concrete mix is known as batching of concrete. Batching can be done by two methods, volume batching and weight batching. Batching should be done properly to get quality concrete mix. Volume batching of concrete. In volume batching, materials are measured on the basis of volume. It is less precise method of batching. Measurement boxes, or gauge boxes, of known volume, are used to measure materials. Cement is taken in the form of bags, where volume of one bag of cement is taken as 35 liters. Volume of gauge box used is made equal to the volume of one bag of cement, which is 35 liters, or multiple thereof. Gauge boxes are generally deeper and contains narrow top surface, and they are made of timber, or steel, or iron. Volumes of different sized, fine aggregate and coarse aggregate are measured individually by these gauge boxes. Water is measured using water meter, or water cans, of known volume. To make 1:1:2 ratio concrete mix, according to volume batching, one should take 1 bag of cement, 1 gauge box of fine aggregate, and 2 gauge boxes of coarse aggregate. If the water-cement ratio is 0.5, then half of the volume of cement, which is 25 liters of water, should be taken. Weight batching of concrete. In this method, materials are measured on the basis of weight. It is accurate method of batching. Weigh batchers, or other types of weighing equipment, are used to measure weight of materials. Cement, fine aggregate, coarse aggregate, and water are taken by weighing. Weigh batchers used are available in 2 types, namely, mechanical weigh batcher and electronic weigh batchers. In mechanical weigh batchers, weights are measured using spring and dial gauge arrangement, and it is widely used equipment in weigh batching. In electronic weigh batchers, electronic scales and load cells, supported by hoppers, are used to measure the weight of ingredients of concrete. Weigh batchers available are maybe manual, or semi-automatic, or fully automatic. Manual type is used for small concrete production job, while other 2 types are used for large concrete production. In case of semi-automatic weigh batching, aggregate container gates are lifted manually, and it is automatically closed after reaching required quantity in the weighing machine. In fully automatic weigh batcher, all the process will be done automatically. The benefit of this type equipment is it also measures the moisture content present in the aggregate and corrects the required quantity of water cement. With respect to moisture content of aggregates, to prepare 1:1:2 ratio concrete mix using weigh batching, measured quantity of materials are 50 kilograms of cement, 50 kilograms of fine aggregate, and 100 kilograms of coarse aggregate. That's all for today.
Next topic would be about mixing. So mixing is simply defined as the complete blending of the materials which are required for the production of homogeneous concrete. So may standard classification system ang mixing. Example nito is 34E-34 cubic feet or 0.96 cubic meters. So rito, yung letter is nag-indicate ng mixer type and yung number naman is rated capacity of the mixer. For mixer type, meron tayong 3 types. S is for construction mixer, E is for paving mixer, and M is for mortar mixer. So as you can see, example natin is paving mixer. So isa pang tip is satisfactory mixing should be obtained as long as the volume of the mix does not exceed the mixer's rated capacity by more than 10%. So These are the examples of construction mixers. First is wheel-mounted na usually ginagamit sa mga small construction projects. Next is trailer-mounted naman, which is yung mga nakakabit sa truck na minsan binabiyahe. And next is stationary plants or large central mix plants na ginagamit usually for large project such as dams na nagre-require ng large quantities of concrete. And lastly is portable plants. So mixer capacities ranges from 3.5 cubic feet or 0.1 cubic meters to over 12 cubic yards or 9.2 cubic meters. So next would be truck mixers. So obviously, itong mga truck mixers are capable of transporting and mixing concretes. And yung product na dinideliver nila is called ready mix concrete. Yung commonly used na truck is transit mixer truck. And yung agitator naman is used for used for transporting plastic concretes galing sa central mix plants. Saka mas capable siya mag-hold ng concrete kaysa mag-mix. So as you can see, standard truck mixer capacity ranges from 6 cubic yards or 4.6 cubic meters to over 15 cubic yards or 11.5 cubic meters. So next naman natin is yung sa paving mixers na. The name itself specially designed for paving operation. So usually ginagamit siya sa mga sa mga daan nga, sa mga highways. Equip sila ng boom and bucket for the placing of concrete at any desired point within the roadway. Ayan, so roadway. So example nito is dual drum paving mixer and single drum paving mixer. Example is 34E dual drum paving mixer. So, yung production ng dual drum mixer is almost double ng single. So, itong 34E can manage 100 cubic yards or 76.5 cubic meters of concrete per hour. So, ito ay example siya ng revolving drum mixer. So, additional information ulit tayo about mixing naman. So yung mixing is may minimum mixing time of 1 minute plus 1/4 minute for each cubic yards, or 0.76 cubic meters over 1 cubic yards or 0.76 cubic meters. And meron ding mixing procedure na nakakatulong sa pag-clean ng mixer drum to provide uniform mixing. Ito yung pag-a-add ng 10% of the mixed water before charging the drum, 80% during charging, and the remaining 10% when charging is completed. Next is nagre-require naman yung truck mixer Manufacturers Bureau ng 70 to 100 revolutions for complete mixing of concrete. Tapos any additional rotation must be at agitating speed. And lastly, concrete in truck mixer should be discharged within 1.5 hours after the start of mixing and before the drums revolve 300 times. So next is magpi-play ulit tayo ng short video for additional information of mixing. Parang process na rin yan. So after concrete mixing design has been established, the volume of plastic concrete produced by the mix may be calculated using absolute volume method. So estimating mixer production na tayo. So for volume in cubic feet, it is just the kukunin lang natin yung weight ng component in pounds all over 62.4 times specific gravity ng component. And kung gusto naman natin kunin yung cubic meters, is weight lang niya, weight ng component in kilograms, then all over 1,000 multiplied by specific gravity. So para mas maintindihan natin is, let's have an example. So for example, letter A, calculate the volume of plastic concrete that will be produced by the mix design given in the table. So ito yung table. So solution for letter A, so cement volume, so yung weight ng cement sa table is 340 all over 3.15, which is yung specific gravity niya is multiplied by 62.4, then we'll get 1.7 cubic feet. So sa baba niya lang is yung computation for cubic meters. So for sand naman is 940 yung weight niya all over 2.65 specific gravity multiplied by 62.4, and we'll get 5.7 cubic feet. And for gravel naman, weight niya is 1,210 all over 2.66 specific gravity multiplied by 62.4, and we'll get 7.3 cubic feet. And for water volume naman is yung water volume natin is 210. Yung water weight natin is 210 all over specific gravity of 1 multiplied by 62.4, and we'll get 3.4 cubic feet. So, para makuha natin yung mixed volume, isa-add lang natin yung mga nakuha nating absolute volume nila. As you can see, pinag-add lang yung 1.7 plus 5.7 plus 7.3 and plus 3.4, and we'll get 18.1 cubic feet. So, that's the answer for letter A. So, for letter B, determine the actual weight of each component to be added if the sand contains 5% excess moisture and gravel contains 2% excess moisture. So here's the solution for letter B. So for excess water in sand is yung, as you can see, yung weight niya uli is 940 multiplied by 5% is yun yung excess moisture niya or excess water moisture niya 5%, so we'll get 47 pounds. And for gravel naman is 2% siya, so minultiply lang yung weight niya sa 2%, so we'll get 24 pounds. So total excess water sa dalawang components is 47 plus 24 is 71 pounds. So for field mix quantities na tayo. So for water, as you can see sa table is 210 siya, and ma-minus lang natin yung nakuhang water nung dalawang components, which is yung 71 yung total. So we'll get 139 pounds. And for sand naman is, as you can see, 940 yung weight niya. I-add lang natin yung moisture, yung excess water. So we'll get 987 pounds in total. And lastly, for the gravel, we'll get 1,210 plus 24 is equals to 1,234 pounds. So that will be the answer for letter B. So lastly, for letter C, determine the weight of each components required to make a 3-bag mix and the mix volume. So for solution for letter C, so adjusting to a 3-bag mix cement is, so sabi nga 3 bags, so 3 multiplied by 94 pounds, or yung, ayan yung standard ng sack, weight ng sack, 94 or 42.6 kilograms. So we'll get 282 pounds for 3 bags of cement. So for computation of sand, 282, which is yung weight nung cement, 3 bags of cement, over 340, which is yung weight ng cement sa ating table, then multiplied by total weight of sand, 987, and we'll get 819 pounds. So ganun din sa gravel, multiply lang natin yung ratio ng 3 bags of cement sa total cement will sa weight ng total weight ng gravel, and we'll get 1,223 pounds. So next for the water is yung weight niya is 139 pounds total weight niya, then we'll get 115 pounds. And lastly for mixed volume, so kung natatandaan niyo, yung sagot natin sa letter A is 18.1 cubic feet by multiplying it to the ratio of 3 bags of cement to the cement in the mix, we'll get 15.0 cubic feet. So that would be the final answer. So next topic, ito naman is about estimating mixer production after batch volume. So formula for it for mixer production in cubic yards per hour is 2.22 multiplied by V times E all over T. So where V is batch volume, T is cycle time, and E is job efficiency. So for our next topic, it is about transporting and handling concrete. So meron tayong different equipment na available for transporting concrete from a mixer to a place of use. So these are the commonly used trucks or equipment. So first one is transit mixer trucks. Next is agitator mixer trucks, dump trucks, conveyors, pumps, cranes, and cranes with concrete buckets. So let's go back. So the height of any free fall should be limited to 5 feet or 1.5 meters unless downpipes or ladders are used. So kapag gumamit naman tayo ng downpipes, having a length of at least 2 feet or 0.6 meters should be used at the end of concrete conveyor. So as you can see, ito yung concrete conveyors and dito ginagamit yung downpipes sa dulo niya. So go back. And of course, there are major factors to be considered for maximum safe hauling distance for transporting concrete. So major factors to be considered are temperature, road condition, track, body type, and mix design. So next is the production of asphalt mixes. So asphalt and other bituminous materials. So first, bituminous materials are dark brown or black semi-solid or liquid thermoplastic mixtures of hydrocarbons derived from natural or synthetic processes in which hydrocarbon mixtures have lost their volatile components, leaving a denser residue. So commonly used are asphalt and tar. So for asphalt, the asphalt is a mixture which consists of alumina, lime, silica, and asphaltic bitumen. At low temperatures, it is in solid state, and high temperature, it is in liquid state. Commonly used siya in surfacing roads and airfields. So yung tar naman is a high viscous liquid which contains high amount of carbon content. It is used for laying surface layer for pavements and preserving wood or etc. So yung properties ng asphalt and tar are almost similar naman except for the fact that not soluble yung tar in petroleum product. And it has different coefficient expansion than does asphalt that can result in severe cracking of the seal coat within a few years. Change in consistency with small variation in temperature, kaya siya in few years prone siya into cracking. So next is bituminous surfaces or pavements and surface treatments. So dahil sa plastic nature nila, they are often referred as plastic pavements, used to provide a roadways-wearing surface and to protect the underlying material from moisture. Bituminous surfaces are produced by mixing solid particles called aggregates and a bituminous material. It bonds the component, that is why it is called as binder. So also referred siya as binder kasi binaband niya yung mga materials. So next topic naman natin would be about aggregates. Aggregates provides the load carrying ability of the surface. So the aggregates also resist the abrasion of traffic and provides skid resistance to travel. Surface consists of any inert non-plastic material passing. So commonly used are coarse aggregate, gravel, which is gravel, or fine aggregate, or which is sand. Mixes often contain the third size called fines or mineral fillers. So passing the number 200 sieves sila lahat, yung fines. So material used as fines includes rock, dust, Portland cement, and hydrate lime. And aggregates used in asphalt mixes should be angular, hard, durable, well graded, clean, and dry. In order na makapag-provide ng tamang strength or required strength to the mix and to the bond with the binder. So next natin is about asphalt cement. Solid form of asphalt. Obviously, asphalt should be heated to get to its liquid state and used to bituminous mixes. Traditionally, viscosity graded based on the absolute viscosity measured at 60 degrees and 135 degrees and range from AC-2.5 Sofyon and to AC-40 which is hard. So meron ding isa pang alternative test, which is yung penetration test na nagre-range from numbers to 200 to 300 to hard, soft, and to hard penetration numbers 40 to 50. So, performance indicate the average grade asphalt binder classification system has been developed. Yun yung PG, ito performance grade asphalt binder classification system. In this system, the first two digit indicate the average 7 to the maximum pavement design temperature in degrees. So ito yung maximum, yung unang digits, and yung pangalawa naman is yung minimum. So parang pabaliktad siya. So next is, these are the following equipments for performance grading system. So ito, first is rotational viscometer. So ayan, meron na siyang definitions. Next is dynamic shear and rheometer. So for rotational viscometer, it indicates asphalt binder handling and pumping properties at high temperatures. And for dynamic shear rheometer naman is provides a measure of the permanent deformation and fatigue cracking of asphalt binder at high and intermediate temperatures. So for ito naman is yung bending beam rheometer, and itong sa baba is yung direct tension tester. So the next one is the rolling thin film oven. So as you can see, para talaga siyang oven. And yung next is for pressure aging vessel naman. So ito, additional information ulit for sa mga asphalt pa rin. Fuel resistant asphalt, often based on polymer modified asphalt or PMA. Ito is available and has demonstrated high resistance to rotting and cracking as well as to petroleum fuels. So asphalt cutbacks, which is liquid at room temperature, is created when petroleum distillates are mixed with asphalt cement. Can be classified as medium curing, rapid, and slow curing. So next would be asphalt emulsions. So asphalt emulsions contain particles of asphalt dispersed in water by means of emulsifying agents. So asphalt emulsions have several important advantages. They can be applied to wet aggregates and they are not flammable or toxic. So classified din sila sa rapid setting, medium setting, and slow setting. So lastly, for road tires, designated sila by symbol RT plus number indicating viscosity naman. Ranges from 1 to 12. So RT-1 low viscosity and RT-12 for solid at room temperature. Dito naman tayo sa handling bituminous materials. So when cutbacks are heated for mixing or spraying, they're usually above their flash point. So what is flash point? Flash point of a liquid is the temperature at which it produces sufficient vapor to ignite in the presence of air and an open flame. Since the flash point is reached at a maximum temperature below that which the liquid would normally burn, extreme care must be taken when heating cutbacks or when handling the heated material. No open flame or spark producing equipment should be allowed near the hot liquid. Use only equipment specifically. So ito po, more on precautionary measures na sa. Use only equipment specifically designed for the purpose when heating, storing, mixing, or spraying cutbacks. Gloves and other protective clothing must be used by workers handling hot equipment. And yung dapat nga ready din yung fire extinguisher equipment together with the personnel na trained sa paggamit nito. Proper precautions and markings for the protection of workers. So next is about asphalt batch plants na tayo. So asphalt plants are primarily used to produce hot mix asphalt, HMA, from asphalt cement. Can be batch plants or drum mix plants. So the one at the top is asphalt batch plant and the bottom is drum mix asphalt plant. So first is batch plants. Uses cold feed hopper and cold feed belt conveyor. So as you can see, ito yung cold feed hopper and this would be the cold feed conveyor. So yung process niya is from the dryer, hot aggregate is moved by a hot elevator into aggregate batcher. So pag akit dito is i-filter na siya nung screen, and by sizes yan, and calibrated feeders provide a supply of aggregate and mineral filler in the required quantities to the plug mill mixer. Now is next na is dito na sa part na to is mag-inject na ng asphalt sa plug mill. The mixture is by then mixed for the required time. The batch of hot mix asphalt is then deposited into a whole unit. So after dito sa part na to is yun na. Sa part na to is yung magde-deposit na sa whole unit or storages or yung sa mga trucks. Next is about naman tayo sa drum mix plant become quite popular and has largely replaced the older continuous flow plant. In this plant, both drying and mixing takes place in the drum. So as you can see, ito yung drum. Dito na gaganap na rin yung drying and mixing ng components. So the process eliminates the separate aggregate batcher, hot elevator, and pug mill of the batch plant. So yun, marami siyang na-eliminate na processes. The dust emitted by the dryer is also less than that emitted by the batch plant dryer because the liquid asphalt tends to trap fines inside the drum. This reduces the amount of pollution control equipment needed. So less pollution yung na-produce na ito. Okay. And innovations, kaya nagkaroon na rin ng dual drum mixers. So next would be about the insulated storage bins na. So insulated storage bins shown in the picture are available to store plant output with hauling capacity is limited or uncertain. So frequent sampling and testing of asphalt plant mixes is required to ensure adequate quality control. Loading and hauling must be carefully conducted to prevent degradation of the mix. So dapat yung trucks ay talagang malinis and dry before loading. So next is estimating asphalt plant productions. An asphalt mix is composed of asphalt coarse aggregate or gravel, fine aggregate as sand, and mineral filler or fines. The amount of asphalt in a mix is expressed as percentage of total mix weight. Aggregate is heated in the dryer to permit bonding with the hot asphalt. For dry capacity, the maximum oily plant capacity may be calculated from the dryer capacity and the percentage of asphalt and fines in the mix. So para mas maintindihan natin is, let's give an example. So for example, letter A, calculate the maximum oily production of an asphalt plant based on the data in the following list. So ito ulit yung table natin for the list. So solution for letter A, plant capacity is equal to the dryer capacity multiplied by 10 raised to 4. So as you can see, yung dryer capacity natin is 110 ton per hour. So input lang natin siya all over 100 minus asphalt percentage. So yung asphalt percentage is 6%, 100 minus 6 lang, multiplied by 100 minus fines. So you can see yung fines natin is itong mineral filler. So also referred din siya, di ba, as fines, so 5%. So in total, we'll get 123 tons per hour. So for letter B, find the required feed rate ton per hour for each component to achieve this production. So ito ulit yung gagamitin nating table. So for solution letter B, feed rate ton per hour. So after getting nga yung kanina, yung plant capacity, ito sa total, i-multiply lang natin yung fraction ng component or yung percentage niya doon sa mix. So yung for asphalt, di ba kanina 6% siya. So multiply lang natin, we'll get 7.4 ton per hour. So sa aggregate, for dry is 94, total of 100% yan. Multiply lang natin sa 123, we'll get 115.6. So by adding, dapat makuha rin natin yung nakuha nating total capacity dito sa ton hour per rate natin. So as you can see dito rin sa baba, yung other components natin, course A, course B, sand and mineral filler, ganun lang din yung gagawin. After we get the plant capacity, multiply lang natin yung percentage ng component, then we'll get the ton feed rate in tons per hour. So yun lang for our report of production of aggregate, concrete, and asphalt mixes. So thank you for listening.